Imagine having the smartest employees in the world, beat, but they are all locked in separate windowless rooms. They literally cannot speak to each other.
Right, they cannot share notes at all.
Exactly. And that is how we currently use AI. Welcome to the Deep Dive. Our mission today is unpacking Jack Dorsey Buzz.
It is a really fascinating open source project.
Yeah, it is a free Slack-style workspace. It solves this exact isolation problem we just mentioned. It turns your scattered AI tools into a cohesive team.
We are exploring how to put Claude Code, Codex, Cursor, Grok, and Kimi into a single chat room.
It's quite the lineup.
Oh, absolutely. We're going to look at the mechanics of multi-agent collaboration. We will cover data ownership, and we will outline the honest limitations of scheduled AI tasks.
Let us start with the core problem here.
Oh.
The modern AI experience is defined by tab fatigue.
Yeah, that is a great way to phrase it.
Context is just scattered everywhere for you. It lives in Claude, ChatGPT, and Cursor.
Right, and it hides in Slack channels and Notion tabs.
It is essentially invisible work. You spend 10 minutes writing a complex prompt. You send it off into the void. And you just hope the model understands.
You are assigning complex tasks to completely isolated tools. But Buzz approaches this from a totally different angle.
It mimics an interface you already understand intuitively.
Exactly. It looks and feels like a normal Slack workspace. You have channels, direct messages, and tags. But instead of just humans, you invite AI agents.
They become your real teammates.
They sit right alongside your human colleagues. The crucial difference is you aren't paying for a new orchestration tool.
Right.
Buzz actually uses your existing agent subscriptions.
I have to make a vulnerable admission here.
Yeah.
I still wrestle with prompt drift myself.
Yeah.
I'm constantly copy-pasting answers between Claude and Codex just to keep them aligned.
Oh, yeah. It completely drains your cognitive load.
It really does. But it's one thing to say they share a room. How does an open source app actually hijack your existing corporate subscriptions without breaking them?
Well, it securely hooks into your local installations. When you message Codex inside Buzz, you are genuinely using your real Codex. I see.
It maintains your existing skills and memory.
So it's a shared control room for the engines you already own.
Perfectly stated. And that brings us to the technical bridge. The protocol making this work is called ACP.
Let me define that jargon for you real quick. A bridge letting chat apps control AI tools running on your computer.
Exactly. And because of ACP, you are not locked into a proprietary ecosystem. An agent in Buzz is just an existing tool, plus a system prompt and workspace instructions.
It is like a plug-and-play suit of armor. You are just swapping the pilot inside the suit. But the suit's overarching mission remains exactly the same.
Right. You could build a custom agent named Harry. Harry uses Codex to research AI tools. 6 months later, you switch Harry's engine to Claude Code.
And the context stays intact.
The history remains perfectly preserved, yeah.
Okay, so we have the bridge to bring them into the room. But how do we prevent these models from talking over each other in the channel?
You use a very specific hierarchy. You assign a lead agent to manage the conversation flow. You assign a lead agent to synthesize the noise into actual decisions.
That is the absolute killer feature here. Multi-agent chats usually get incredibly messy, agents repeat themselves, and over-explain simple concepts.
Yeah, they do.
Buzz fixes this with a shared thread. It uses the lead agent pattern. You just tag multiple agents in one message.
You give them a single directive.
Right. You say, one of you, take the lead, talk through the plan, disagree, then execute. One searches the web, another checks old contracts. They actually debate in the open channel.
Wow.
And then the lead agent finalizes the decision.
This is essentially a high-end restaurant kitchen.
Oh, I like that analogy.
Yeah, the lead agent is the head chef expediting the ticket. The cheaper models are the sous chefs prepping the ingredients, so the head chef doesn't waste energy chopping onions.
That is the smart model strategy in a nutshell. You pin strong models like Codex or Claude to hard tasks, things like system architecture or legal review,
Right.
And you use cheaper, faster models for summaries and first-pass reviews. Even with just one single Codex subscription, you can use a parallelism trick.
Setting parallelism to 5, 10, or 20.
Exactly. It lets Codex handle multiple tasks simultaneously. It acts like a small, synchronized team.
That kitchen analogy works great for text.
Yeah.
But what about the friction of constantly typing out these complex multi-agent instructions?
You actually don't have to type them out at all. Buzz lets you manage these workflows through audio.
Right, we can just speak to them directly through voice huddles.
It moves Buzz away from a standard chat box. It becomes an immersive working environment. You can start a voice call in a channel with Codex and Claude.
I have to push back slightly on that.
Mm-hmm.
Human thought processes are incredibly messy out loud. We ramble constantly.
Yeah, you do.
How does an AI parse that efficiently?
Well, that is the brilliant part of the engineering. Buzz transcribes the audio, but the agents only reply to the actionable parts.
Oh, wow.
Yeah, they systematically filter out all the human rambling.
So we were just talking about breaking the text barrier. And there's an iOS app that really expands this.
Yeah, you just scan a QR code to securely sync your phone.
You can send a task while walking to get coffee. Codex. Make 3 landing pages. Claude, please review them. You return to your laptop, and the work is moving.
It completely decouples you from the keyboard. Buzz also has a projects feature. It acts exactly like a Git repository.
Agents create local folder copies of an application.
Right. It keeps them from stepping on each other's toes. Claude works on the front end. Codex works on the back end. Then they push the code to GitHub.
With all of this sensitive code and voice transcripts living in one app, we have to ask a critical question. Where is all this deeply valuable agent context physically stored?
Buzz avoids the standard corporate cloud model. They use a relay architecture instead.
We keep the data on our own relay, entirely bypassing third-party servers.
Data sovereignty is non-negotiable here. You can self-host the relay or use a company like Block. The crucial point is your team controls the shared memory layer.
Because agent context is immensely valuable intellectual property. Project decisions, refined prompts, deep research.
And since it is open source, anyone can fork Buzz. You could build a visual canvas view for PDFs tomorrow.
You could turn it into a full co-working system.
Yeah.
Yeah.
But under settings, there is a shared compute feature. Buzz detects your computer specs. It lets others in the community use your hardware to run local agents.
Beat. Whoa. Imagine an agent economy. People sharing hardware, agents actually paying other agents for compute power to solve a problem. That is a wild frontier.
It really is a massive frontier for decentralized computing. But bringing it back down to earth for a moment, how can a listener start using this today without getting overwhelmed?
The onboarding is very approachable. You just download it for free, you let it auto-detect your installed agents, install the ACP connector, and pick a default lead agent.
Start small. Install Buzz, connect one lead agent, and build from there.
That is the best way. Pick the model with the most useful context for you. The sources also mention using OpenRouter. You paste an API key to access a massive list of LLMs in one place.
Yeah, it lets you mix expensive and cheap models easily.
And what about the management agent?
Oh, that is a narrow Codex agent with one job. It checks your email, Slack, and Notion at fixed times, say 9 a.m. and 12 p.m. It delivers a prioritized action list.
That sounds incredible. But the sources give a reality check on automation here.
Yeah, scheduled workflows are not fully reliable yet. The problem isn't capability, it is trust.
It really is. An agent might say, it's 9 a.m., checking email, but fail to execute. It's refreshing to hear that we shouldn't just hand over the keys to the castle yet. Trust is the bottleneck, not technology.
Exactly. You can create a checker agent to verify completion, but that adds mental load.
What is the ultimate takeaway regarding automated scheduling?
Stick to supervised workflows.
Keep humans in the loop for now. Trust supervised peer review over blind automation.
Let them debate the architecture, but you must pull the final trigger.
Let's take a moment to summarize this paradigm shift.
Beat.
We are moving from a world where we assign tasks to isolated tools. Now, we are assigning roles to an integrated AI team. Jack Dorsey Buzz provides the open source room for that team to talk. They debate and refine work before it ever reaches human eyes, while letting us keep ownership of the resulting data.
It changes how we scale our work completely.
It does. And I want to leave you with something to chew on. Beat. If our AI agents are going to spend all day peer reviewing each other, catching mistakes, and debating solutions in a shared room, at what point does the shared context of the AI team become more valuable than the institutional knowledge of the human company itself? 2-sec silence. Thank you for taking this deep dive with us. Out to row music.